So, good evening everyone. Can you hear me? Yes, okay. So, I share my screen first of all. Can you see my screen? Okay.
Recording in progress.
So, hi and welcome to the third day beginners course on Google Earth Engine. So, today our course content will be, first of all, we will discuss about the computation using the satellite images. So, mainly in this part we will try to show you the different type of satellite imagery. Then we also try to show you how you can easily calculate it, the different type of indices using the satellite imagery band. Okay, it will be NDVI, NDWI or other indices. We will try to show you how you can easily calculate the band computation using the satellite imagery in Google Earth Engine. Okay, then we also discuss about the Landcover classification map, and this is the introductory part, so I will not go in depth in the Landcover classification map, but I will try to show you the basic part of the Landcover classification using the Google Earth Engine, so that you can easily understand all of the procedure, so how you can develop the Landcover classification map in Google Earth Engine. I hope after completing this session you can easily make the Landcover classification map in Google Earth Engine. Then we also try to make the LULC map, Landcover classification map in Google Earth Engine. Then how to export this map as a TIFF format, we already covered this part yesterday. We also try to show you that today session, so that we can easily understand how you can export the TIFF format as a LULC map. Okay, then how to import the ArcMap software and make the map layout. Okay, so this is the first of all we discussed about this already. So then we also move to the air quality monitoring. Mainly in this time we will use here the Sentinel-5 satellite imagery. Then we can calculate the some air quality parameters such as nitrogen dioxide or other indices. Okay, we will calculate the monitoring using the Sentinel-5 imagery. Then we also filtering and displaying the Sentinel-2 imagery, how you can easily filter and display the Sentinel-2 imagery, and we also calculated the NDWI from the Sentinel-2 imagery. In this part we will cover this. Okay, so we will start our today's session. So we will start, so we will cover the another topic from the previous day topic. I will cover it first of all. So previous day topic we will cover the how you can easily export the shapefile from the Earth Engine. Okay, so we will cover this first time, we will cover this part, then we will move to our today's session. Okay, suppose you can make a vector file or raster file, then you want to export this imagery as a shapefile from the Google Earth Engine. Okay, so first of all we will cover this part, then we will move to our today's session. So for this you can easily export the any shapefile. It will be reverse shapefile or it will be any shapefile you can export from the Google Earth Engine and use this shapefile in other software, just ArcMap or QGIS easily. So for this you can see here, this is the satellite. I simply click to the satellite, then I can get the satellite view. Suppose I want to make a shapefile for this lake, for the lake of this lake. I want to make a shapefile for this lake. So first of all we need to digitizing. Okay, digitizing our area. I want to make a shapefile for the lake of Hatirjil Lake. Okay, so for this first of all you need to make the digitizing. So in this time I simply take this polygon. Okay, I simply digitize my area. I randomly digitize. Okay, so you can make the any river shapefile or any shapefile from easily and very quickly and efficiently you can do this using this Google Earth Engine platform, and you can easily export this shapefile and use this shapefile any software, ArcMap or QGIS, and it also be georeference shapefile. Okay, so we can easily use it any other software, just ArcMap or QGIS. So I randomly digitize this area. Suppose this is our area, I digitize my lake. So now I want to export this part as a shapefile so that I can easily use this shapefile with other software. Okay, so now you can see here our code will be added the geometry, and here the 64 vertex I can add this part. When I digitizing it, then new code line of this code will be added here. So first of all, I need to simply use a feature collection, okay, so that all of this geometry or vertex will be at the feature collection. So for this I take a variable, I simply take a variable, and if you can see this is the default variable name. If you want you can change it or not, it's totally depend on you. I simply change it AY, it is my area of interest. Okay, so now I simply take a variable. After this variable I make the feature collection, all of these things. Okay, so I simply put here a variable, and this variable, and I gave this variable name is, you can use the any variable name. I simply put the variable name is AY collection. You can use the any variable name, it's totally depend on you. Okay, collection. So in this time I want to make the feature collection all of this vertex. Okay, you can see there the total 64 vertex we can see here. So I can simply use here the ee dot feature collection. This is the function, it will be collected all of this together. So I simply use here the feature collection, and after this I simply use here the vertex name. This is my AOI, I simply put this. Okay, so now it will be added here. So now I want to export this shapefile. So for this I simply use this function. This function name is export dot table to bride. Okay, then I simply put here my keyboard on the control and backspace. You can see all of this argument will be available. I simply put all of this argument one by one and make a dictionary, so that I use here the curly bracket between two sides. Okay, I simply use the curly bracket between two sides and put all of this information one by one. First of all, collection, this value comes from our this feature collection where I put this AY new collection. I simply copy this and paste here. After this description can be anything, it's just the name of your file. I simply put here my this file is the, I can give this name is the Hatir Chill. Okay, then folder is the specific folder which you want to create in your Google Drive. I simply use here the 5th base. Okay, then file name prefix is not needed for this time, I simply remove it. File format is needed for this time because I want to make this file format as a shape file. So for this I simply use here the SHP, this extension, and select not needed for time, and other it's not needed for time. I simply remove it. Okay, so now you can see it will be generate, and when I simply click to the run, you can see our task tab will be running. It will be yellow color. I simply click to here, then you can see I simply click to the run, and then you can see all of these things will be good. I simply click to the run, Now it will be running, and after this, when it will be completed, then you can easily check your Google Drive and you can easily download the shapefile, and you can use this shapefile for your any reason, or you can use this shapefile for the any software, ArcMap or QGIS very easily. Okay, so you can see here I make the code randomly code, and it will be stored in my Google Drive. But if you want, you can also make a link. Okay, make a downloadable link, and that link will help you directly download it. When you can simply click to the link, then this shapefile will be directly downloaded. Okay, so now I will try to show you how you can easily make a downloadable link, so that when you click on the link, the shapefile will be automatically downloaded. Okay, so for this, now I will try to show you make a URL, so that this, when you click to the URL, just this shapefile will be automatically downloaded. You don't need to go to your Google Drive or other things. Okay, so for this I simply take a variable. I take the variable, and after this I simply put this variable name is AOI URL. You can give any variable name. I simply put the AOI URL, and then I simply call my feature collection variable name. Here you can see my feature collection variable name is AOI collection. I simply call this variable. And after this I simply put here a function. This function name is get download URL. This function generate a link. So anyone, when you click to the link, this shapefile will be automatically downloaded. You don't need to go to your Google Drive and then download it. Okay, so just now I will try to show you. You can easily make a URL. When you simply click to the URL, then the shapefile will be automatically downloaded. Okay, so this is the very easy way. So that I will try to show you this. Okay, so then I can simply put my here. You can see, first of all, first argument I can make a dictionary, so that I use here the curly bracket between two sides. Okay, I make a curly bracket between two sides. So first of all, format. So you define the format. What is your file format name? So in this time, my file format is the shapefile. So I simply use here the S. It is the capital SHP, and then it's not needed for this time. I simply remove it. Then file name, I can simply put my file name. Suppose my file name, I can give this file name is it will be anything. So I simply put here the file name is Hatirjil shapefile. Okay, I put here this Hatirjil shapefile. Okay, and call back. It's not needed for this time. I simply remove it. Okay, so now I simply print my URL, so that anyone can, when go to this link, so that it will be automatically downloaded. You don't need to go the Google Drive or other. Okay, so I simply print this, and then I simply call the AOI URL. Simply paste here, and when I click to the run, you can see our console tab will be running. I can simply go to the console tab, and you can see this is our link. Okay, when I simply click to the link, you can see automatically opened a browse window, and our shapefile will be automatically downloaded. You can see our shapefile will be automatically downloaded as a zip format. Okay, so now I simply open this. You can see this our shapefile will be automatically downloaded. This is our file. I simply unzip this file. It will be unzipped. You can see this is our file, and here you can see all of the shapefile will be available. It will be .ssx, .ssp, .prj, .dbf, .cpg. Okay, all of this file will be available, and now you can use this shapefile for your any geospatial software, just ArcMap, QGIS, or ENVI, or other geospatial software. You can easily use this shapefile. Okay, okay. So I hope you understand this part. If you have any question, then you can ask me. Any question?
Yes. দাদা যেটা জিজ্ঞেস করছিলাম, এই যে লিঙ্কটা আপনি করলেন, এই লিঙ্কে যে ম্যাটেরিয়ালটা রয়েছে, এই ম্যাটেরিয়ালটা কোথায় গুগল সার্চ ইঞ্জিনের সার্ভারে সেভ হচ্ছে না
Yeah,
আপনার গুগলে?
it will be save in your Google server, so that you can easily, anyone can use this link and it will be downloaded from the Google server, Google Earth Engine server.
আচ্ছা, আমরা গুগল আর্থ ইঞ্জিন সার্ভারে তাহলে কতটা পর্যন্ত আমরা সেভ করতে পারি?
250 gigabyte.
আচ্ছা, 200, যেটা প্রথম দিনে বলেছিলেন ওইটা।
Yeah. So
আর একটা জিনিস যেটা, যে সেভ ফাইলে ক্রিয়েট করলেন, সেভ ফাইলের মধ্যে যদি আমি কোনো অ্যাট্রিবিউট কলাম অ্যাড করতে চাই, তো সেক্ষেত্রে কি করা যেতে পারে?
So we can add here the attribute table, and this is the another option. I think we can also add this. So in this time we will not go this in part. Okay. So it will be possible for the add the another. Suppose you want to make the just the WebGIS or web mapping, something like this. I can define this point,
Yes.
and I define here that this is my add some information. Okay. So we can also do for in Google Earth Engine, but this is the another part. In this time I will not go in this time. Okay. But it will be possible as a vector data shape. We can do it, no problem. So just you can see here, you can, I will try to show you how you can easily download it any shape file. Okay, so it is clear for me. Is that possible to collect the point data training during the supervised classification? Yeah, it's possible. Suppose you want to make a supervised classification and now you want to collect some training data. After this you can easily download this training data as a shape file. Okay, so you can easily do it. This is the same procedure. Okay, you can select some urban, water or other body, then you can easily
Yes.
download this part as a point shape file easily. Okay, so this is the
Okay.
common part for how you can easily download any shape file or the any training point or other as a vector format. We can download the anything as a vector format using this step. Okay, so I hope you understand this part. So we will now
Yes.
yeah. Okay, so now we will go to my next slide. Today's session will start now. So first of all we will try to sum this introduction to Landcover classification map. So Landcover classification map is the observe the biophysical cover of the earth surface. We can easily use the land use and land pattern, then we can easily predict the land change trends. Okay, using the land cover and land use data we can easily change our trends in land use and land classification. So now what's the process to make the land cover classification map in GE? And this process is same for all of the satellite imagery. It will be Landsat or Sentinel, all of the classified or classifier. This process will be same for all of this. Okay, so first of all you need to selecting your region of interest. You want to select your region of interest. It will be your shape file. Okay, you can easily import and export this shape file. I already covered this part. Okay, then you need to choosing and filtering the image collection, and I already covered this part for the Landsat imagery, how you can easily filtering and choosing your image collection. We already show this part. And Sentinel imagery we will be completed this part is in this today's session, and we also try to show you how you can filter the Sentinel-2 imagery in Google Earth Engine, and after this calculate the NDWI. And Landsat imagery we already covered this part. Okay, so your second step is that you need to choosing and filtering the image collection. Okay, then you need to collecting the training point. You can collect the training point for the every feature. It will be urban, it will be vegetation, or which feature you want to classify. Just you can collect the training point. Okay, then you need to merging all of this training point together using the EE feature collection. We merging all of this training point. Okay, after this we make a training data set. Okay, we make the training data set from the merging training point by using the sample region function. Okay, so after this you can merging the training data set, then you make a training data set. After merging the training point, then you make the training data set by sample regions, and then you need to create the classifier and classify the images. So in this time Google Earth Engine has a lot of classifier, but this is the introductory part, so that's why I cannot go in the depth in the classifier. We can randomly use a classifier. so that we cannot go in the depth the classifier, because there are the lot of classes need for the complete this session for the land use classification map in Google Earth Engine. So I randomly show you a one classifier so that you can use this classifier and make the classify image easily. Okay, so then create the classified images and display the result. So today's session I will try to complete all of this step, but in Google Earth Engine, in the Landcover classification map has a lot of extent. You can, if you want, you can also calculate it the each feature. If you want, you can also make the change trend. If you want, you can also make for the accuracy assessment. All of these things will be possible in Google Earth Engine platform for making the Landcover classification map. But this is the introductory part, so that's why I will not go in the depth of the Landcover classification classes. So now we will continue our part. So I will try to make a small project for LULC map using the Google Earth Engine. I will explain this project as well as also make the new project, so that you can easily understand every step and how you can use this code easily. Okay, so first of all, you can see this is the Landcover classification map of Saglain sub-district of Bangladesh. So this is our code link. You can easily access this code link from here. So now I will explain this code one by one and also make a Landcover classification map for Dhaka city. Okay, so I can simply copy this code first of all and open my browser. And I will follow this step, every step one by one. So this is our step. Okay, first of all, our step selecting our region of interest. So first of all, we already know that how you can easily import and export the shapefile. Suppose in this time I will make a Landcover classification map for the Dhaka city. I simply put this Dhaka city shapefile. I select my ROI, so I can give this name is ROI. You can use the any name. I simply show my razor ROI in my map interactive view. So I simply use this function. We already cover all of these things, so I will not explain again. Okay, focusing my center. Okay, so first step is done. I completed the first step. This first step is that selecting your region of interest. I want to make a shapefile. This is my region of interest. I select this. Okay, then second step is that filtering and choosing your image collection. We can use the Landsat, we can use the Sentinel imagery. So in this part I will try to show you how you can use the Landsat imagery. You can simply search at the Landsat 8 top of atmospheric dataset. I simply, and we already explained all of these things, how you can easily filtering and displaying the Landsat satellite imagery in Google Earth Engine. So I will not go in depth in this time, so I just work on this. Okay, I simply put this collection, top of atmospheric collection. Okay, you can see this image collection is the default variable name. I simply change it. This is the image. I can give this is the image. Okay, or I can give this name is L8. Sorry, L8. You can use any name. I simply put the L8. Okay, and then I simply select my specific image. I simply use here the image, and then I simply filter, and all of these things I will explain our previous classes. Filter metadata. I simply use here the cloud cover. it will be less than, I can using 1, and then
মিজান ভাই ক্লাউড বানানটা একটু ভুল হয়েছে মনে হচ্ছে।
filter date, I suppose I want to make this for the year of 2020. Okay, and then I take here the median image, and after this I click with my region of interest ROI. Okay, and then I want to show this result, display this result. I simply use here the map dot add layer function, and then I simply use here the image. This is my object name, and I will simply click to the run, and we also complete all of these things our previous classes, so that I will skip in this time. So now you can see our image will be ready, but now we will need to the reflectance, increase the reflectance, as well as also need to the band combination, so that our image will be more readable and looking good. Okay, I simply click to the configure button, and then I simply select here my true color composite B4, B3 and B2. Okay, and then I simply increase the stress 98%. Okay, then apply, and then import this visualization parameter, and after that I simply copy this and paste here. Okay, then I also gave this name. This name is the true color. Okay, so now our second step for the filtering and visualizing the satellite imagery of our specific region of interest will be completed. Now our third step. Our third step is for the collecting the training point for every feature. Okay, suppose I randomly collect some of the training points in this time from our satellite imagery. You can training point you can collect for the this point, or if you want you can also make the rectangle. Okay, so I simply collect from some training point from here. This is the water body. I collect some the water body. First time I collect water body.
If I want to turn off the shape file layer, then what to do?
You want to turn off shapefile. So if you have the ground truth data, suppose if you have the ground truth data, then you can make the shapefile point of the every feature. Then you can easily import this shapefile as if you are the training point. Okay, suppose you can get some the training data from the field and make the shapefile point. Okay, then you can also use this for here, no problem. Then your map will be accuracy very good, because you can collect the training point from your ground field. We can easily good result. Suppose I can take the for here. So now you can see this is a geometry, and I can simply click to the edit layer. Then I can give this its name I can simply put the name is the T water or training data for water. I can give this name, and then I simply use here the feature collection, import as feature collection. Okay, then property, I can give this property, and property will be same for all of these things. I simply use the Landcover, and value it will be start from the 0. We will indexing. So first of all, tree water is 0, then urban is 2, or vegetation is 3. We can indexing from the 0. It will be start from the 0. We will indexing from here, and property will be same for all of these things. Okay, so I simply click to the OK. So now we can see I take the training data for the water. Okay, then we will collect the same training data for the urban. Okay, so I simply click to the new layer. You can see this is the new layer, and I will configure it. First of all, I simply click to here, and I can simply give this name is the T urban. Okay, and then I simply use here the feature collection, imported feature collection, and then it will be property will be Landcover. This will be same for all of these things. Okay, Landcover, then value it will be 1. Okay, I simply click to OK, and then you can see it will be, when I simply click to the T urban, it will be black portion, and now I want to collect some the training data for the urban. So here you can see here the lot of urban, I simply collect from the urban. Here the lot of urban will be available, I simply randomly collect from the urban. Okay, this is the urban, I collect from the training urban. Then I will collect from the vegetation. Suppose I simply click to here, then also give this name is the T vegetation. You can use the any variable name. I simply use the training of vegetation. Okay, then import as it will be feature collection, and then property I can give the same property, it will be Landcover, and value it will be 2. Okay,
2
I simply put
Yes.
here, and then I can simply put here the some collect from the vegetation. So here the very less vegetation, so I simply use here the some green portion for indicating the vegetation. Okay,
আরেকটা জিনিস যেটা মানে আপনি যে এতগুলো স্যাম্পল কালেক্ট করছেন যে কোনো একটার জন্য, তো এগুলোকে মার্জ করার কোনো প্রয়োজন নেই, অটোমেটিক হয়ে যাচ্ছে মার্জ নাকি?
no, after training the all of this point, then we will go to the merging option. We will merge all of this together.
Okay.
Just we need the function merge, then it will be automatically merging all of these things. Okay, so I think this is the vegetation. Okay, we randomly collect for the vegetation. Okay, then we collect for the some bare land. Suppose it will be T bare land, and then geometry it will be feature collection, and property will be same for the Landcover, and it will be value will be 3. Okay, then I collect some the bare land from here. Okay, we collect from the training. Okay, so now you can see I divide here the 4 part of the getting the training point: T urban, T water, T vegetation, T bare land. Okay, so now our process is that to merging all of this training data set. Okay, so for this we need to use the merging function. We will explain this code also here. So you can see this is our project, so we already complete this. Okay, so in this case you can see here, first of all we selecting our ROI, then move to our visualizing and displaying the satellite imagery, and then we can put all of this satellite imagery one by one training data. Okay, so here you can see already training the T water, T urban, T vegetation, T bare land. We collect the some training point. Okay, like this. Okay, so now we need to merging all of this training data together. So for this you can use the merging function. I simply just copy from here, so that you can merging the feature. I simply use here the same code, so that I simply copy this. So it will be merged. You can see I use the T water, this is my T water, it will be merged with the urban, then it will be merged with the T vegetation, and it will merge with the T bare land, and all of this merging data will be stored this the class names. Okay, and now I want to show how many point will be available this time. So I simply get the information about all of these things. So I use here the class names variable. I want to print this and get this result from here. So I simply click to the run. So it will be computing. So here the total 52 elements. I simply check all of these things. You can see every feature will be available, geometry, and you can see property, it is the Landcover 0, and it will be indicating the 0 is the T water or training data for water. We can get all of this training data, merging all of this together. Okay, so now we need to make a training data set. You can see, so first of all I collect some the training point from here, so from the satellite imagery. Then I will merge all of this training data set, and after this I simply create the training data set from the image collection and make a training data set in this time. After this, when I complete the training data set, then we want to train this data set using the classifier and make the classified images. So that's all processes will be okay. So now I simply use here the sample region function, and then I simply create the training data set using this training point, merging the training point, all of these things. Okay, so for this we need to, first of all, we need to select our extract band values. Okay, suppose in this time I will simply select these bands value. I want to use these images, selection images, and use the bands for predict our Landcover classification. Okay, I simply copy this part. Okay, so in this time I simply select my bands, make a list. I will make a list and select my specific bands. Then I simply use a variable. I write this code so that you can easily understand. I simply use the, gave this variable name is training. I simply use here the same, so that training. Then I need to call my image collection. So in this time you can see my collection variable name is the image. I simply call this image, and then I select my specific band. So here I already defined my all of this band, which band I want to use for the predict for my Landcover classification. So I simply use the bands, and then I need to use here the function. This function name is sample region, sample regions. Okay, so now you put all of this argument one by one as a make a dictionary. So then it will be make the training data set. After making this training data set, you train your data set using the classifier of Google Earth Engine classifier, then create the classified images. Okay, so now I will make a dictionary in this time. So I simply make the dictionary one by one. So first of all, collection. This is our collection, and this collection is comes from our merging training data set. You can see this is our merging. So I simply copy this, and then properties. And properties, we already defined the properties. You can see we also use the properties in this here. You can see this property is the Landcover. It will be same for all of these things. So I simply use here the, we can also use for the same property. You can see this is the Landcover. I simply use here the our properties value, keyword value is the Landcover. Okay, and then scale. Scale is the resolution of your satellite imagery. It will be 30 meters. Okay, and projection is not relevant. I simply delete this, all of this argument in this time. So now I want to show this training data set. So I simply print this training. I simply print this